work energy equation is work done by the forward forces minus the work done against the backward forces, and that is equal to the change in the kinetic energy plus the change in the potential energy, which is the gravitational potential energy. Okay, so as we know, change is always final minus initial. So delta KE is equal to half mv square minus half mu square, or we can say it is half m into v square minus u square. Similarly, change in potential energy is mgh final minus mgh initial, or we can take mg as common, so it will be height mg into height final minus height initial. We will not think in terms of this concept that loss in one, gain in the other, like that. No, simply put the values according to these formulae, so you will automatically get your results. So work is always equal to force times the distance, and the component of the force which is parallel to the direction of motion, that will be F. And we always multiply it with S. And here the condition is that this F is always constant force. Because later we will see that when the force is not constant, so then we will not use this formula. We will have another formula in terms of power. Okay, so now let's do some questions. So I have chosen these questions from the previous edition of this book. So this is the question from the previous edition of the book. So using this work energy equation, we are solving it. So a box of mass 20 kilogram is pulled up a ramp inclined at 30 degrees to the horizontal. So we always draw the situation. So this is a ramp inclined at 30 degrees to the horizontal, and a box is taken from here to some position up the ramp because there it is pulled up 10 meters, it is pulled up, so this distance moved is 10 meters. So the work done in moving the box 10 meters is 1200 joule. It means this is the work done by the forward force, because the forward force always bring the item from one place to the other place. So this is given as 1200 joule. And calculate the magnitude of the average resisting force. So it means the backward force we have to find. So according to the situation which is given to us, we will assume that the object is taken up 10 meters with a uniform speed. So I will write here that assuming it is moved uniformly. Moving uniformly means that constant speed. Constant speed means that the change in kinetic energy will be zero. So we can say in this case delta KE is equal to zero. Remember, change will be zero, not the kinetic energy zero. Because initially and finally it will have the same kinetic energy. So when you subtract, it will be zero. Okay, so backward force we are to find. So putting this information in this work energy equation, so work done by the forward force 1200 minus the work done by the backward force will be the backward force times the distance it moved 10 meter, and that is equal to change in kinetic energy, which is zero, plus change in the potential energy, which is mg height final minus height initial, m20 g10, and height final is this height. In the diagram I will show. So it is taken from here to here. So from here to here. So this height is 10 sine 30. So initial height is 0 and the final height is 10 sine 30. It's going up. Okay. So here we can write final height is 10 sine 30, which is actually 5, and minus the initial height is 0. Okay, so then just using calculations, we can find the backward force. So minus, here no need to put the unit m, just you can put 10. So 10 bf is equal to, it is 5. So this will be 200 times 5,000 minus 1200. So which means the backward force will be equal to, it is minus 200, so divided by minus 10 will be 200 over 10. That is equal to 20 Newton. So 20 Newton is the backward force, which is the average resisting force. Okay, so then we shall have another question. This one. So a cyclist freewheels down a slope inclined at 15 degrees to the horizontal. So again, we can draw the diagram like this. So cyclist is here with the cycle. So freewheeling means going downwards. But this case, it is changing its speed also, increasing its speed from 4 meters per second to 10 meters per second. So it means here the speed is 4 meters per second. And when it reaches at the bottom, its speed is 10 meters per second. It's not compulsory that you will say that it reached to the bottom. It may be somewhere here. So the speed at that, when it be here, anywhere, it will be 10 meters per second. So now the cyclist will be here after the motion. So it has covered 50 meters on the path, which means that the initial height will be according to the angle, which is 15 degrees. So it is 50 sine 15. Okay. So now we can apply here the mass. Total mass is 60 kg of the bicycle and the cyclist. We always consider the total mass. So free wheel means that no driving force. Some information are hidden in the statement. Free wheel means that the driving force is 0. It means no forward force. And one important point I will write here, that while using the work energy equation, so using this equation, never take the weight as a force. Weight or its component we will never take as a weight force, because it is already considered in the delta PE. That is actually the work done by the weight or by against the weight in both cases. So on the left side, we will not take the weight as a force. So W sine theta we will not take here. Okay. So now the work energy equation is this. And simply putting the values in this, so this will be 0 because driving force is 0. So the forward work done is 0 minus the work done again the backward force. So calculate the mean resistance to the cycle. Again, we have to find the resistive force. You can say the backward force, or you can say Fr as a resistive force, time the distance moved. Remember that some students forget to multiply by the distance. So you will not forget this. You will recheck this value that you have multiplied or not. Okay. So then this will be equal to half m fixed t into final speed square minus the initial speed square, and then plus m into g into h final minus h initial. H final, when it is at the bottom, the speed is, sorry, the height is 0, minus the height here is 50 sine 15. Okay. And then the only unknown is Fr, so which you can find easily. Fr will be equal to all this thing divided by minus 50. Automatically you will get the positive sign. See, we don't need to put any sign from ourselves that some loss is there, so we put negative sign. So that method which you are using in physics is having a little bit complication. So if you use this formula, even there, you will feel that this is quite easy. Okay. So then you can complete this question. So these many Newton is the answer of this.